In this video, we are going to practice graphing the secant function and the cotangent function. But let's start with the secant. Now, I need to rewrite this equation. Right now, it's sort of looking like I'm going to have a phase shift of pi over 4 to the left. Oh no, that would be wrong. Understand that x over 4 is just like having 1/4 x. So I have a b value of 1/4 trying to happen. When you have a b value, though, you need to factor that b value outside of the parentheses. So I need to take that 1/4, put it out in the front, and then figure out what I'm going to have inside the parentheses. So I'm going to have 1/4 and then x plus something. But to know what that something is, I need to divide pi over 4 by 1/4. What are you talking about? So I need to do pi over 4 divided by the 1/4. So, we multiply by the reciprocal when you have fractions. So I'm going to do pi over 4 times 4 over 1. These are just going to cancel out. So I'm just going to have pi. So I'm going to have pi right here. Okay, so this is what the equation should really look like. Now let's talk about the period. The period is always the natural period divided by the b value. For sine and cosine and secant and cosecant, the natural period is 2 pi. So we're doing 2 pi divided by the b value. In this case, that means 2 pi divided by 1/4. Again, we multiply by the reciprocal in this case, so that's 2 pi times 4. So that is 8 pi. So that's the period, 8 pi. Then there's the phase shift. Remember, look at this version of the equation. Alright, the phase shift is pi, well, negative pi. It's the opposite of this sign. So because of the plus pi, I'm going to put negative pi, and then just for good measure, I'm going to say left. Now, they also want the asymptote equation, but I'm going to do that at the end. Asymptote equations. Whatever. I'll do that at the end. So, this is going to be in my way, so I'm going to erase this now. Alright, whenever there is a phase shift, I always like to start with the phase shift. So that's what I'm going to do. Here's my x-axis. For sine and cosine and secant and cosecant, we only do one period. So I'm going to go ahead and put a mark here. But since I'm only doing one period, I'm going to just go to the right. So 1, 2, 3, 4 spaces. This should be enough for one period of a function. So again, the phase shift is left pi, or negative pi. So that's why I'm going to put a negative pi at the very first mark. And now, going to the right, every one of these marks is 1/4 of a period higher. So I need to add a 1/4 of a period to find what the next values are going to be. So let's see. 1/4 period. Well, so since the period is 8 pi, a 1/4 period will be 8 pi divided by 4. So that's just going to be actually 2 pi. So a 1/4 period is 2 pi. So that's going to make this really simple, because I'm going to start at negative pi, and I'm going to add a 1/4 period. So I'm going to add 2 pi. Negative 1 plus 2 is 1. So I'm going to have 1 pi. If I add 2 more, I'm going to have 3 pi. Alright, I was putting these down here so I could reduce, but I can now see that there will be no reducing. So I might as well put it on the line. So I'm going to have pi, and then I'm adding 2 more, so that was 3 pi. Adding 2 more is going to be 5 pi. Adding 2 more is going to be 7 pi. So these are the x values I'm going to use to create this graph. Alright, now this is in my way, so I'm just going to go ahead and erase this. Now, I need to have the y-axis represented on here, so I can mark my a value. The y-axis is always at 0. I don't see 0, but I see I have a negative and I have a positive, so I know that the y-axis will be between those. So I'm going to go ahead and put my y-axis between the negative and the positive. If there was a 0, I would put it there. Now the a value is 1. See how you don't see any number there? Alright, so the a value is 1. So that's why I'm just going to go ahead and mark 1. So this is positive 1, and down here will be negative 1. There is no vertical shift, so the x-axis is my midline. I'm going to put an optional yellow dotted line at the a value to help me with my graph. Alright, that is not mandatory, but it helps me. And I will do the same thing below at the a value. Okay. Now I'm ready to do my graph. You know, I guess I should put it to the left as well. A little bit. Secant is the reciprocal of the cosine function. 1 over cosine. That's what secant is all about. So, I know what the cosine function looks like. It starts off up high at its highest value. So, I'm not going to start on the y-axis. Don't do that. Remember the phase shift at negative pi? That's where we begin, at the phase shift. So cosine starts off up high, so I'm going to put the dot there. Ignore the y-axis kind of, because then I'm just going to fall to the midline, and then cosine goes low, and then back to the midline, and then cosine goes high again. Now, of course, I'm supposed to be graphing secant, not cosine, so I'm not going to really draw a dark graph. I'm just going to graph this very lightly and dot it. I'm just using this as a guide to do my secant function in a moment. Okay, so there's my cosine function. Now, everywhere the cosine function is touching the midline, there should be an asymptote there. It's really obvious why that is when the midline is the x-axis, because right here is where cosine is 0. So since secant is 1 over cosine, if cosine is 0, that's undefined. So that makes it obvious why we have an asymptote wherever the cosine touches the midline. So I'm going to put an asymptote right here because it touches the midline right here at pi. I'm going to put another one here at 5 pi, another vertical asymptote, another dotted line. Okay, now the actual secant function has some points in common with the cosine function, and it's the highs and lows. It has those points in common. Okay, because the reciprocal of 1 is still 1, then it has this in common. The reciprocal of negative 1 is still negative 1. Okay, so these points don't actually change when you do the reciprocal, so I can use them. Now, so using those points, I'm just going to approach the asymptote, going away from the midline. So I'm going to simply approach the asymptote. Okay, and here I'm just going to approach the asymptote on the left, approach that asymptote on the right, and I'm going to approach this asymptote. And that's it. That's what one full period of the secant function is going to look like. The blue is the secant function. So we're finished except for the asymptote equation. So what I like to do is pick one of the asymptotes I've graphed. I usually start with the first positive one, or 0 if it happens to be an asymptote. So the first positive asymptote is at pi, so I'm going to start with that. So a vertical asymptote always is of the form x equals. So x equals pi represents my first asymptote. So how far do I have to go to get to my second asymptote? Well, I have to go half of a period to get to the next one. I know it's half of a period because it's only 2 spaces away. The full period is 4 spaces. This is only 2. So that's half of a period. So look, a full period is 8 pi. So half a period must be 4 pi. So that's what I would have to add to get to the next asymptote. So I'm going to say pi plus 4 pi. Now I'm going to put this multiplier in here. This would get me to the next asymptote. And think about it. Pi plus 4 pi, pi plus 4 pi would be 5 pi. And notice that gives me the next asymptote. If I added another 4 pi, it would give me the next asymptote, and so on. But all I have to do is put a multiplier n on there, and then that will give me all of the asymptotes, just depending on what n is. If n is an integer. Okay, and you have to mention that. Integers can be negative as well, so or even 0. So if n is 0, it gives us the original asymptote that we started with. But if n is negative, it starts to give us the asymptotes going to the left. So that is the asymptote equation. Alright, that's going to do it for number 27. And let's go ahead and squeeze in one more graph. Alright, let's graph cotangent. I'm going to have to change the way this equation is written. I see the b value and a phase shift trying to happen. I won't see it clearly until I rewrite. The b value needs to come outside of the parentheses. So I'm going to have x minus something. To know what goes here, I need to divide pi by the 2. Well, that's just going to be pi over 2. Okay, so that should be all inside of parentheses with the cotangent and the y equals out front. So this is the version of the equation I'm going to use. Now let's talk about the period. The period is always the natural period divided by the b value. For tangent and cotangent, we have learned that the normal period is pi. So since the b value is 2, then that means the period for this problem is going to be pi over 2. Okay, so the period is pi over 2. Okay, the phase shift. When we talk about the phase shift, we're looking at this blue version of the equation, where we can see that the phase shift is right here, the h. And it's the opposite sign of what you have in the equation. So the phase shift will be positive pi over 2. And I'm going to go ahead and say to the right, just for good measure. Now they also want to know the equation of the asymptotes, but we'll do that at the end. So let's go ahead and do the graph. So look, before I do the graph, let me just mention what we know about tangent and cotangent. Imagine that this is the midline. Alright, and here's another midline. For the tangent graph, one period of the tangent function will begin and end on the midline with an asymptote in the middle. For the cotangent function, it begins and ends with an asymptote with a point right in the middle on that midline. So we have basically memorized this. Now the tangent function is always increasing. So as I approach the asymptote, it will go like this. And as I start from the bottom and go to the right, again increasing as it goes to the intercept. So there's your your basic tangent period will look like. Meanwhile, cotangent is a decreasing function. So it's going to start off up high and decrease as it goes to the intercept. And then it's going to continue to decrease as it goes to the other intercept. So this is how we will draw one period of the cotangent function. So tangent begins and ends with a point. Cotangent begins and ends with an asymptote. Alright, so this is cotangent, so when I draw it in a moment, just keep in mind that it's going to begin and end with an asymptote with a point in the middle. Now, before I get too carried away, remember the phase shift. Whenever there's a phase shift, when I draw my graph, I always start at the phase shift. So normally, I would start at 0. But because of the phase shift, I'm going to put a mark right here, but I'm not going to label it 0. I'm going to label it positive pi over 2 because of the phase shift. Okay, not because of the period, because of the phase shift. So I'm going to call this positive pi over 2. For tangent and cotangent, we have to do 2 periods, not just one, like we do for sine, cosine, secant, and cosecant. So because I'm going to do 2 periods, I'm going to make 4 marks to the right, like I always do, 1, 2, 3, 4. But because I'm doing 2 periods, I'm also going to do 4 marks to the left. So 1, 2, 3, 4. So these 9 values I'm about to have will be the 9 values that I'm going to graph. I need to label all of these. So in order to find out the value at each one of these positions, I need to keep in mind that every one of these marks is 1/4 of a period higher as I go to the right. 1/4 of a period. So if I think about it that way, so I'm going to ask myself, what is a quarter period in this particular case? Well, a quarter period, of course, is 1/4 of the period. The period for this problem is pi over 2. So it's 1/4 of pi over 2. So a quarter period in this problem is going to be pi over 8. So if I want to get this next value, I should be able to add pi over 8, and that should give me the next value. Of course, I need like denominators here. So what I would do is I would multiply by 4, numerator, denominator. That would give me 4 pi over 8. So if I add a quarter period, if I add 1 pi over 8, then the next mark over will be 5 pi over 8. And then if I keep adding 1 pi over 8 over and over again, I'm going to get 6 pi over 8, 7 pi over 8, 8 pi over 8. I need these 4 positions to the left as well, so I'm going to subtract 1 pi over 8. So to the left, I'm going to get 3 pi over 8, 2 pi over 8, 1 pi over 8, and 0. Next, the last one would be 0. Now, I put these down so low to leave myself room to reduce. So, 5 pi over 8 does not reduce. But 6 pi over 8 is 3 pi over 4. 7 pi over 8 does not reduce. But 8 pi over 8 is pi. 3 pi over 8 does not reduce. But 2 pi over 8 is pi over 4. And then 1 pi over 8, of course, is just pi over 8. And 0 is just 0. However, I'm going to need the y-axis. So just remember that this is 0, and that's why I'm going to put the y-axis here. I'm going to go ahead and erase all this pink stuff now that I'm through with those calculations. Okay, this was 0, remember, so this is where the y-axis is going to go. Alright, the a value is 1 because I don't see anything there. So I'm just going to go ahead and mark a 1 and a -1 like you do. Alright, for my a value. There is no vertical shift, so the x-axis itself is the midline. I am going to use the a value when I do the graph, so I'm going to go ahead and put in an optional yellow dotted line to help me correctly graph the a value when needed. Okay, so I'm going to do that above and below. This is optional, but it really helps your graph look good. Recommended and stuff. Okay. Now, remember what I told you about the cotangent. I told you that the cotangent begins and ends the period with a vertical asymptote. Also remember that we started at pi over 2. So that's where I'm going to put my first asymptote. So cotangent begins and ends with a vertical asymptote. So I'm going to put a vertical asymptote at the phase shift, and then I purposefully counted over 4 marks because this will be the end of the period. And like I said, cotangent is going to begin and end with a vertical asymptote. And I also said that there would be a point at the midline right in the middle. So here's the point on the midline right in the middle. Now I'm going to do the same thing for this period over here. I already have my asymptote right here. I'll do my best to put an asymptote over here, but because the y-axis is here, that's going to make it a little bit hard to see. I think I'll go pink so you can kind of see it. So I want you to be able to tell that this is in fact a vertical asymptote happening. Okay, I know it's hard to see, but this is also an asymptote. And right in the middle, again, there should be a point on the midline right in the middle. Now, cotangent is a decreasing graph. Unlike tangent, which is always increasing, cotangent is decreasing. So, if I start from one of these points, for example, either one of these points, as I go to the right, I should be decreasing towards the asymptote. I should be falling toward the asymptote. So I'm going to do that, but halfway over, it should be at the a value. So I'm going to put it on the yellow line. That's why I put the yellow line here. So now I'm going to go ahead and fall, but as I do, I'm going to make sure that I hit that point. Alright, so it should be something like that. Now on this side, again, I have to fall from up high, so I'm going to fall towards this intercept. But halfway over, it needs to hit the a value. So I'm going to just make sure that I hit. Wow, I'm really doing these lines crooked. So forgive me for that. Will my OCD take over and cause me to try again? I try not to redo stuff because I'll be here all day if I start to get into that game. Alright, that's slightly better. Okay, and I'm going to do the same thing over here. So I'm going to fall and then fall some more. But as I fall halfway over, I need to be at the A value. So it's going to be, oh wow, why am I doing such a bad job with this right now? Sometimes I can do this much better. But not today. Not today. Alright, and I'm going to fall some more, but halfway over I'm going to hit this A value. So as I fall, I just need to make sure that I hit that point. Okay, so this is what 2 periods of your cotangent function will look like. The only thing left for us to do is to write the equation of the asymptotes. And so what I like to do is just pick an asymptote. I usually pick the first positive asymptote, like pi over 2, unless there's an asymptote at 0, which is, I find, even better. So there happens to be an asymptote at 0, so I'm actually going to start with that one. So a vertical asymptote always takes the form x equals something. So x equals 0 represents my first vertical asymptote right here at the y-axis. How far do I have to go to get to the next asymptote? Well, I have to go a full period. See how it's 4 spaces away? That's a full period. So in this case, a full period is pi over 2. So that tells me I have to add pi over 2 to get to the next asymptote. And if I added 2 pi over 2, that would give me the next asymptote. 3 pi over 2 would give me the next one. 4 pi over 2, 5 pi over 2, 6 pi over 2 would give me even more. So if I put n pi over 2, that will represent all of the many, many asymptotes that I will run into. If I call n an integer, that will even capture the asymptotes going to the left, because an integer can be negative. If n is 0, then that will give me the original asymptote that I started with. Speaking of 0, it is silly to put 0 plus something. You know, like, what's 0 plus 5? 0 plus 5 is just 5. So we don't really want to put the 0. I wouldn't take off for it, but you really don't need the 0. So we will just write x equals n pi over 2, and that's it. And that's going to be it for this problem. Take one more gander at this beautiful graph, because this is what a graph of 2 periods of the cotangent function will look like. I hope this video has been helpful. I will see you on the next video.